Yes, it is permissible to run 120-volt power circuits for booster panels and beam detectors in the electrical metallic tubing conduit with non-power limited fire protection cable. According to the National Electrical Code, NPLFP cable is permitted to be installed in the same raceway with power limited fire alarm circuits, even if the power limited fire alarm circuits are 28 volts or less. The National Electrical Code Article 760.126 paragraph B number 1 states that power limited fire alarm circuits and non-power limited fire protection cables can be installed in the same raceway. National Electrical Code Article 760.43 paragraph B states that non-power limited fire protection cables must be kept separate from power and non-power limited cables by a physical barrier, for example a partition or divider. This can be achieved by using a multi-compartment raceway or by physically separating the cables within the raceway. Firstly, ensure that the 120-volt power circuits are physically separated from the power-limited fire alarm circuits by a barrier. This can be a barrier within the electrical metallic tubing conduit or provided by a separate raceway. Secondly, the 120-volt power circuit should be properly protected by circuit breakers or fuses. Thirdly, follow all applicable grounding requirements for both the power-limited fire alarm and power circuits. By meeting these requirements, one can safely run 120-volt power circuits for booster panels and beam detectors in the electrical metallic tubing conduit alongside the non-power limited fire protection cable for the power limited fire alarm circuits. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It's updated every 3 years and provides the foundation for safe electrical practices. When dealing with fire alarm systems, several articles within the NEC are particularly relevant. Article 760 covers fire alarm systems. It outlines the requirements for wiring, equipment, and installation of fire alarm systems to ensure reliability and safety. Key sections within Article 760 address power sources, circuit protection, and wiring methods. Article 725 pertains to Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. While fire alarm systems primarily fall under Article 760, understanding Article 725 is useful because power-limited fire alarm circuits are often categorized similarly to Class 2 or Class 3 circuits. This article helps in understanding the limitations and wiring methods for these types of circuits. Article 300 contains general wiring methods. It covers topics such as wiring in raceways, cable installation, and protection against physical damage. These general requirements apply to fire alarm systems as well, ensuring that the wiring is installed correctly and safely. Article 310 focuses on conductors for general wiring. It provides guidelines on conductor ampacity, insulation types, and installation requirements. Selecting the correct conductors is critical for the reliable operation of fire alarm systems. For example, fire alarm conductors often need to be fire resistant. Article 314 deals with outlet, device, pull, and junction boxes, conduit bodies, fittings, and handhole enclosures. These components are integral to any electrical system, including fire alarms. The NEC provides rules for box fill, support, and installation to ensure that connections are made safely and remain accessible for future maintenance. Article 250 covers grounding and bonding. Effective grounding is essential for safety and to minimize electrical noise that can interfere with fire alarm system operation. This article provides detailed requirements for grounding electrodes, conductor sizing, and bonding methods. Article 110 addresses requirements for electrical installations. This article includes general provisions for working space around electrical equipment, guarding of live parts, and identification of components. These rules are essential for the safety of electricians and other personnel who may interact with the fire alarm system. NPLFP cable, or non-power limited fire protective signaling cable, is a specific type of cable used in fire alarm systems. It is designed for circuits that are not power limited, meaning they can carry more current and voltage than power-limited circuits. These cables are typically used for the main power supply to fire alarm control panels or for circuits that power devices requiring higher energy levels. NPLFP cable is designed to withstand fire conditions for a specified period, maintaining circuit integrity to ensure that the fire alarm system continues to operate during a fire. This is achieved through special insulation and jacketing materials that resist burning and melting. This cable type is suitable for use in raceways, conduits, and other approved wiring methods, providing flexibility in installation. The NEC specifies the requirements for the installation and use of NPLFP cables, including proper support, protection from physical damage, and separation from other types of wiring. PLFA circuits, or power-limited fire alarm circuits, are low-voltage, low-energy circuits used for signaling and communication within a fire alarm system. These circuits are designed to limit the amount of power they can deliver, reducing the risk of electrical shock and fire ignition. PLFA circuits are commonly used for connecting initiating devices such as smoke detectors and pull stations to the fire alarm control panel. They are also used for notification appliances such as horns and strobes. The NEC specifies that PLFA circuits must be wired using specific types of cable, such as FPLP or fire protective signaling power-limited cable. These cables have special insulation and jacketing materials that are fire-resistant. PLFA circuits must be installed in accordance with NEC guidelines, including proper separation from non-power-limited circuits, appropriate overcurrent protection, and proper grounding. Electrical metallic tubing, commonly referred to as ENT, is a type of rigid metal conduit used to protect electrical wiring. It is made from galvanized steel or aluminum and is designed to be lightweight and easy to install. EMT is commonly used in commercial and industrial buildings to provide a protective raceway for electrical conductors. It is suitable for both concealed and exposed applications and can be bent and cut to fit specific installation requirements. The NEC specifies the requirements for the installation and support of EMT, including the use of appropriate fittings, connectors, and supports. Proper installation of EMT helps to protect electrical wiring from physical damage, moisture, and other environmental factors. The decision to run both 120-volt power circuits and fire alarm circuits in the same conduit depends on several factors, primarily related to safety, code compliance, and the specific requirements of the installation. In many cases, it is permissible to run both types of circuits in the same conduit, but there are specific conditions that must be met to ensure safety and compliance. According to the NEC, power-limited fire alarm circuits, or PLFA, and non-power-limited fire protective signaling cables, or NPLFP, can be installed in the same raceway. This is typically allowed under the condition that the NPLFP cable is used for the fire alarm system's power supply and the PLFA circuits are used for signaling and communication. If both types of circuits are allowed in the same conduit, it is essential to provide a physical barrier between them. This can be achieved by using a multi-compartment raceway or by installing a divider within the conduit to separate the power circuits from the fire alarm circuits. The purpose of the barrier is to prevent the potential for electrical interference or accidental contact between the different types of circuits. All electrical circuits must be properly insulated to prevent shorts, ground faults, and other electrical hazards. When running both 120-volt power circuits and fire alarm circuits in the same conduit, it is crucial to ensure that all conductors have the appropriate insulation rating for the voltage and application. The NEC specifies the types of insulation that are suitable for different wiring methods and environments. All electrical circuits must be properly grounded to provide a safe path for fault current in the event of an electrical fault. When running both 120-volt power circuits and fire alarm circuits in the same conduit, it is important to follow all applicable grounding requirements for both types of circuits. This may involve installing a separate grounding conductor within the conduit or bonding the conduit to ground at specific points. It is important to consult the NEC and local electrical codes to determine the specific grounding requirements for the installation. In addition to the NEC, local electrical codes may have additional requirements or restrictions on running different types of circuits in the same conduit. These local codes may be more stringent than the NEC, so it is important to be aware of them and comply with them. Local authorities, such as the electrical inspector, can provide guidance on the specific requirements for the installation. Before starting any electrical work, it is always a good idea to consult with a qualified electrical engineer or licensed electrician. These professionals can help to ensure that the installation complies with all applicable codes and standards, and that it is safe and reliable. They can also provide guidance on the selection of appropriate wiring methods, conductor sizes, and overcurrent protection devices. A physical barrier inside the conduit is essential to separate the 120-volt power circuits from the power-limited fire alarm circuits. This barrier prevents direct contact between the conductors, reducing the risk of electrical interference and accidental shorts. The barrier can be a physical divider, a separate raceway within the conduit, or any other approved method that provides effective separation. Proper overcurrent protection is crucial for both the 120-volt power circuits and the power-limited fire alarm circuits. Overcurrent protection devices, such as circuit breakers or fuses, protect the wiring and equipment from damage due to excessive current flow. The overcurrent protection devices must be sized appropriately for the conductors they protect, in accordance with the NEC and local electrical codes. Grounding ensures a safe path for fault current in the event of an electrical fault. Both the 120-volt power circuits and the power-limited fire alarm circuits must be properly grounded in accordance with the NEC and local electrical codes. This may involve installing a separate grounding conductor within the conduit or bonding the conduit to ground at specific points. Proper labeling is essential to identify the different types of circuits within the conduit. The 120-volt power circuits and the power-limited fire alarm circuits should be clearly labeled at both ends of the conduit, as well as at any junction boxes or termination points. This helps to prevent accidental contact with the wrong circuit and makes it easier to troubleshoot any problems that may arise. Following industry best practices ensures a safe and reliable installation. In addition to complying with the NEC and local electrical codes, it is important to follow industry best practices for electrical work. This includes using high-quality materials, making neat and secure connections, and testing the installation thoroughly before energizing the circuits. The safety of the fire alarm system is paramount. The purpose of a fire alarm system is to detect and alert occupants to a fire, allowing them to evacuate safely. Any electrical work that is performed on the fire alarm system must be done in a way that does not compromise the system's reliability or effectiveness. The type of raceway used is a crucial consideration. Different types of raceways offer varying levels of protection and have different installation requirements. Electrical metallic tubing, or IM, is a common choice for fire alarm systems, but other options, such as rigid metal conduit, or RMC, or flexible metal conduit, or FMC, may also be suitable depending on the application. The choice of raceway should be based on the specific requirements of the installation, including the environment, the type of wiring, and the level of protection needed. The conductors used for both the 120-volt power circuits and the fire alarm circuits must be of the appropriate size and type for their application. The conductor size must be large enough to carry the maximum current that the circuit is expected to draw, without overheating. The conductor type must be suitable for the voltage, temperature, and environmental conditions in which it will be used. The connections made within the conduit must be secure and reliable. Loose or corroded connections can cause a variety of problems, including voltage drops, overheating, and even electrical fires. The connections should be made using appropriate connectors and fittings, and they should be tightened to the manufacturer's specifications. The National Electrical Code, Article 100, defines a raceway as an enclosed channel designed expressly for holding wires, cables, or busbars, with additional functions as permitted in the NEC. Raceways can be made of metal or insulating material. The term raceway encompasses various types, including rigid metal conduit, intermediate metal conduit, electrical metallic tubing, rigid polyvinyl chloride conduit, flexible metal conduit, and cable trays. The code recognizes these as suitable for different applications, each with its own set of installation requirements outlined in Chapter 3 of the NEC. Metal raceways offer robust physical protection to conductors from impact, abrasion, and other mechanical stresses. When properly grounded, they also provide an effective path for fault currents, enhancing safety by facilitating the quick operation of overcurrent protection devices like circuit breakers or fuses. This grounding capability is crucial in minimizing the risk of electric shock and fire. Insulating raceways, such as PVC conduit, are lightweight and resistant to corrosion, making them ideal for use in environments where exposure to moisture or chemicals is a concern. However, they do not inherently provide grounding, so a separate grounding conductor must be installed within the raceway. Article 300.3 paragraph B number 1 addresses the installation of conductors of different systems within the same raceway. It generally permits the installation of conductors for different systems in the same raceway, cable, or enclosure, provided that all conductors are insulated for the maximum voltage of any conductor within the raceway or enclosure. This rule simplifies installations by allowing multiple systems to share the same physical space, but it mandates a high level of insulation to prevent faults. Article 300.11 addresses securing and supporting raceways and cables. This section requires raceways and cables to be securely fastened in place. Independent support wires, straps, or hangers must be used. This ensures that the weight of the raceway and its contents is adequately supported, preventing strain on boxes, fittings, and connected equipment. Proper support is essential for maintaining the integrity of the wiring system over time. Article 314.16 covers the volume of outlet device and junction boxes. This section specifies the minimum volume required for boxes based on the number and size of conductors, devices, and fittings contained within them. Ensuring adequate box fill is critical for preventing overcrowding, which can lead to conductor damage, overheating, and potential safety hazards. Article 358 specifically addresses electrical metallic tubing. EMT is a lightweight, thin-walled conduit commonly used for protecting conductors in various environments. It must be installed with approved fittings and supports and is suitable for both concealed and exposed work. EMT is not threaded, connections are made using set screw or compression type connectors. EMT provides good mechanical protection to conductors and can be easily bent and cut to suit specific installation requirements. Article 344 addresses rigid metal conduit. RMC is a heavy-walled conduit offering superior mechanical protection to conductors. It is typically made of galvanized steel, stainless steel, or aluminum and is suitable for use in harsh environments. RMC is threaded and connected using threaded fittings, providing a robust and durable raceway system. Article 356 covers liquid-type flexible metal conduit. LFMC is a flexible conduit with a liquid-tight jacket designed for use in wet locations or where flexibility is required. It is commonly used to connect equipment that is subject to vibration or movement. LFMC provides good protection against moisture, chemicals, and physical damage. Article 310.15 provides guidance on conductor ampacity. This section details how to determine the allowable ampacity of conductors based on their size, insulation type, and installation condition. It includes tables and adjustment factors to account for ambient temperature, the number of conductors in a raceway, and other factors that can affect a conductor's ability to dissipate heat. Selecting conductors with adequate ampacity is crucial for preventing overheating and ensuring reliable operation of electrical systems.